Hello everybody, welcome to your linear algebra review of linear versus nonlinear equations. My name is Jason and I work with University Academic Success Programs. We oversee a lot of the tutoring services available at all of the ASU campuses. So to get started, let me give you an example of what a linear equation is. So for a linear equation, you're allowed to choose whatever variables you want. I'm going to go ahead and say x and y. And what you can do with them is you can multiply them by constants. For instance, I could multiply by 3. I could multiply this one by pi. And you can also add them together or subtract them if you like. So let's say I subtract these, and I can set them equal to some other constant. Let's say 17 over the square root of e. Okay? This equation that I have developed here is linear. The reason it is linear is because both of my variables, my x and my y, are both to the first power. They're not being squared, they're not being cubed, there's no trigonometric function that's acting on them, there's no logarithm we're taking of them, we're not raising them to exponents, nothing like that. They're just an x and a y, and we're allowed to multiply by constants, we're allowed to add those variables or subtract those variables, but that's it. We are not allowed to do anything fancy with them. For instance, an example of one that would not be linear would be, say, 3x1 squared minus pi times the square root of x2 plus 11x3 equals 14. So in this case, I went with 3 variables. And this term, this 11x3, that term is linear. All we have is a variable being multiplied by a constant. But these terms up here are not linear, because my first variable, my x1, is being squared in this case. Over here, my x2 is being square rooted. Neither of those are linear. Okay, so to be linear, I have to just raise my variable to the first power. So let's go through the examples we were provided here and determine which ones are linear and which ones are not. So question A, we have 5x1 plus 3x2 equals 17. So if we look at our two terms, this 5x1, that's linear, right? Because the x1's being raised to the first power, and all we're doing is multiplying by a constant. Same thing back here, the 3x2, that's also linear. And what am I doing with them? I'm adding them together, which is totally fine. So the left-hand side looks linear, the right-hand side is just a constant. So overall, this one is linear, okay? This one is linear. Okay, now let's go over to question B. Question B. So if we look at our terms here, we have 0.3x. For the reasons we mentioned before, that's definitely linear. But then we come over here and we have this 5xy. Now, are we allowed to do that? Are we allowed to multiply two variables together and it still remain linear? I know we're allowed to add them together and we're allowed to subtract them, but are we allowed to multiply? And the way that I like to think about this is, imagine if they weren't two different variables. What if instead they were the same variable? So if I had negative 5x times x. Well, x times x is x squared, right? And that's certainly not linear. That is quadratic. So if they were the same variable, we wouldn't be allowed to multiply them together. That rule holds over if they're two different variables. Okay, so we are not allowed to multiply two variables together or divide two variables because that would make it non-linear. Okay, so our example B is non-linear. Go ahead and write that. This is not linear. Cool. Part C, we already see right off the bat. This term is being squared, so it is certainly not linear. So to be linear, every term has to be linear, right? So this term's fine, that term's fine, but this x squared is not fine. So this is not linear, okay? Over here, x1 is fine, but right here we're taking the sine of x2. So as I mentioned before, you can't take trigonometric functions, you can't take logarithms, you can't raise as exponents. None of that is allowed. So this one would also be not linear. Okay, we come down here to question E. So up front here, our first term, the 9 plus e cubed times x. So the x is fine, right? It's just being raised to the first power. We look at this e term, and it's being cubed. But the thing is, that's totally fine because e is a constant, right? So e cubed is also just some constant. And then adding 9 to it is still just some constant. So this 9 plus e cubed is just an arbitrary constant. So this first term is just a constant multiplied by a variable, which is totally fine. So we're allowed to do funky stuff with the constants. We can raise them to powers. We can take trigonometric functions of them. We're just not allowed to do that to the variables. And then we look over here, the same case, right? We're taking the cosine of something, but that thing we're taking the cosine of is a constant, not a variable. So that's totally allowed. And then we just have z hanging out. That's totally fine. And again, the right-hand side is just some constant. So overall, e is linear. Okay. And then we look at our last one. We have this trouble area right here, where we have this variable x2 being raised as a power. So we automatically know it is not going to be linear. Not linear. Okay. Wonderful. Well, thank you for joining me. Over here on this slide, I have some additional resources available to you. As I mentioned, I work for UASP, and we oversee a lot of the tutoring resources on all of ASU's campuses. So for more information about the free resources that we have, please visit tutoring.asu.edu. If you want specifically more videos that go over specific content from your course, or maybe review session information for upcoming exams, you can go ahead to this link down here. Thank you very much. Have a great day.